Everyone, today I'm going to talk about one of the most important topics in Calculus 1, so-called the L'Hopital rule, to define the limits of some functions. So in this problem we have to define the limit of this fancy function here. So let's get started. As we know, we are given the limit as x tends to 0 of this expression here. If I just plug 0 instead of every single x in the expression, I will have infinity minus infinity as given in the statement of the problem. But as we know, this is one of the indeterminate forms. In order to solve this kind of problems, as a first step, we have to define the common denominator for these two fractions. Now let's apply the limit, again, as x tends to 0. So if I plug 0 instead of the x, I'm gonna have 0 over 0, which is a big problem. Now we have to use the L'Hopital rule in order to get to the result. And according to the L'Hopital rule, we know that the limit remains all the same as the very first step. As the next step, we have to derive both numerator and denominator. But you gotta be careful here. You're not supposed to use the quotient rule. You have to define the derivatives of numerator and denominator separately. So derivative of x is 1, and of sine x is just cosine x. In denominator, we have the product of two functions. So basically, I have to go for the product rule. Derivative of the first function is 1, the second one remains all the same. I have to add, first one remains, derivative of sine x is gonna give us cosine x. Every time you apply the L'Hopital rule, you have to plug the number in. So if I plug 0 instead of the x's, I will still have 0 over 0. So it basically means that I have to go for the L'Hopital rule once again. Again, I'm gonna derive numerator and denominator separately. In numerator, we have the constant, so it is gone. And derivative of the cosine is negative sine. Since we have here one more negative, it is gonna give us sine x. In denominator, it is going to give us cosine x, and here we again got the product rule. So derivative of x is 1, cosine remains, and x remains, derivative of the cosine x is the negative sine x. For that reason, here we have the negative sign. Now let's plug the number. If I plug 0 in numerator, I will have sine 0, which is going to give us 0. In denominator, cosine 0 is 1, and here we still have 1. And where the third expression gonna give us 0. So as we can see, we are gonna have 0 over 2, which is obviously not the indeterminate form, so the result gonna be just 0.